So before we get super excited about drawing Lewis structures, you have to make sure you can count how many valence electrons there are in your molecule or polyatomic ion. So just remember, you're going to tot up the number of valence electrons based on their position in the periodic table. This is coming from the fact that Lewis structures are dealing with your NSNP configuration. So for instance, if you're in group 7, you're going to have, let's pick on chlorine, for instance. Chlorine has got a 3s2, 3p5 configuration. So 2 s electrons plus 5 p electrons gives you 7 total valence electrons. If it is an ion, for anions, they are gaining electrons. So you have to add the charge of the anion to the valence electron count in total. And the flip side of that is if you have a polyatomic cation, cations lose electrons, so you have to subtract electrons equivalent to the charge from the valence electron count. Okay, so make sure you do know how to deal with whether you've got an anion or not. Okay, so the nitrate ion. Okay, so valence electrons count. We've got nitrogen, we've got oxygen, and we've got a charge to deal with. So we've got one nitrogen atom. Nitrogen is in group 15, so it has 5 valence electrons. That's coming from a 3s2, 3p5 configuration. No, it's not. 2s2, 2p5 configuration. Sorry, I was just looking at lithium and going 3, 3. More coffee required. So 1 times 5 valence electrons coming from that nitrogen. We got we got 3 oxygen, and each oxygen, you see, it's in group 16, so it has 6 valence electrons coming from a 2s2, 2p4 configuration. 2 plus 4 is 6, so 6 valence electrons. And then the charge is a -1 charge, so we have to add an extra valence electron coming from that -1 charge. So what do we end up with then? 5 plus 3 times 6, that's 18, 23, plus 1 is 24 total valence electrons. Okay, so let's do another one to just practice. Okay, so I think there's a cation here. It's really hard to see because it is underneath the notes I gave you about anions gaining electrons. So you have to add the charge to the count of the valence electrons, and cations are losing electrons. So you have to subtract the charge from the valence electron count. So I'm going to see if I can reveal our methane diazonium ion. There it is. Okay, so let's count our valence electrons up then, see what we got. So we have got, one carbon, and carbon has got 4 valence electrons, okay, because it is sitting there in group 14. It's got a 2s2, 2p2 configuration. We've got 3 hydrogens, so it's 3 times 1 valence electron. Let me just pull this periodic table so you can see it. And then we've got 2 nitrogens, and each nitrogen's got 5 valence electrons sitting there in group 15 with a 2s2, 2p3 configuration. And then our charge is +1, so it's lost 1 electron. So we're going to have to minus 1 valence electron from our overall total. So we've got 4 plus 3 is 7, plus 5 is 12, minus 1. Have I done that right? I don't know if I can add anymore. I think that's 11 valence electrons, but I also might have stuffed this up. No, because I only added 1 nitrogen. Silly me. Right. 4, 5, 6, 7, plus 10 is 17, minus 1 is 16 valence electrons. Okay, so we should have a total of 16 valence electrons in this species.